Hello, Bhavna, am I audible?
Hello, sir. Yes.
Okay, so yeah, today I'll be trying to complete the rest of the chapter. Okay. Alright, Bhavna, so last time we completed the rectangular, what was that? Parallelogram law of vector, right? But we were left to do the analytical method. We need to say a basic calculation part. So today we will be doing the analytical method for each of them, okay?
Okay,
Analytic,
sir.
analytical analysis, or let's say the treatment of triangles law. First, we will go for the triangles law. If you can understand triangles law in a proper way, then parallelogram law is also the similar way. In parallelogram, just a thing is shifting is happening. Okay, that's the triangles law of vector. So, what was the triangles law? As per the triangles law, if two vectors are there, if two vectors are there,
And
as
they
per
form a cycle.
the triangles law, two consecutive sides of triangle. If two vectors are there which represents two consecutive sides of a triangle, then we can simply say the third side will be represented by the resultant, right? Reverse of the resultant. This is
Yes,
the
sir.
right. Then third side should be like this. This should be the third side. Okay, this is going to be the third side. But the third side is represented by the reverse of resultant. So what will be the resultant? The reverse of it. Okay, because this is the third side and it is shown by the reverse of the resultant. So this should be the resultant as per the triangles. Okay, so that's assume this is a triangle. So A, B vector, and what is the next? That is resultant vector. Okay. When I say analytical method, we have to calculate exact values of resultant and all. That's the thing. So, in a general method, which we have already studied from the previous things, you know that a resultant of two vector will come out as r square equals to a square plus b square plus 2ab of cos theta, is it? Right? We have already studied this part. But we came
Yes.
across this just by a normal resultant because it's low. At the end of the day, we are going to get the same relation, but things will be a little bit different. Okay? Here we'll be taking how differently we are treating the elements. So here we can simply say, no, no, what I will try, no, I will try to extend this vector from here. I took this and I extended this vector. Okay. Similarly, I will extend it from this point such that this comes out perpendicular to this. Is that clear? So vector if this thing is written. Yes. This is a vector B. So yeah, this is perpendicular. Okay, is that clear, Bhavna? So Bhavna, if you see carefully, I have two different right angle triangles. Okay, one you can call it as this is point O, okay, O P Q R. You can say we have uh, O P Q as one triangle and O P R as another triangle. Okay, can I say this?
Yes, sir.
My whole of the discussion is going to be in this way. Okay, assume this is the theta. So this, if you see carefully, it is nothing but if you just extend this A will come out here. So you can simply say that this is A, this is B, this is B. So this theta is nothing but the angle between A and B. Okay, so theta
Okay.
angle between A and B, A vector and B vector. Okay. So let's go with the first O, P, and R vector. Let's go for a bigger vector. Okay. So if we just go for a bigger vector, what I can say that due to a Pythagoras theorem, I can simply say that OP of square is coming out to be this is QP of square. Sorry, QP of square coming out to be OP of square perpendicular square plus Q times of 4 square. Can I say this
Yes.
by Pythagoras? That's fine. Okay, what is OP? I can simply say this is nothing. This length is nothing but the resultant magnitude, right? So I will write this as just R square. Fine. What is O? What is OP? OP is I have not calculated, so just leave it for now. And what is QO? Again, let it be. If you see the QO, Q is O is nothing but sum of QR plus sum of R, right? So it will become sum of two things. One is Q times of R plus O times of R, okay? And square of the total square. That's fine. Let's look at the values of each of them, okay? For this, I will be going for the smaller triangle. So let's go for a triangle PRO. If you go into this, what you are going to notice that, mm, okay, you will notice that again this is making a Pythagoras theorem, right? So as per the Pythagoras theorem, if I consider what I can consider, okay, let's not take the Pythagoras. I will say cos theta. What is cos theta? If I do the cos theta, I will be getting this length. What is this length? I can simply say that it is nothing. This particular length is nothing but by this base upon hypotenuse. What is hypotenuse? That is B. B is magnitude, right? Okay, let's
Yes.
O and R for definition. So from here you have got OR is equals to B times of cos theta. I don't know. Like, I don't think we should have gone through this way because we have already studied the resolution of vector part, right? So by the
Yes.
resolution of vector, also I can say this this length comes out as B of cos theta, and this perpendicular length should be coming out as B of sine theta, right?
Yes.
So by this I can say if this is sine theta, just parallel, this will also be a B of sine theta. So two P's are there, whatever it's up to you. We can just substitute the values, the rest of the values. So R square is equals to OP. If you see what is the OP, OP is nothing but um, B times of sine square theta. Okay. Uh, about this part, what is that? That comes out as QR. What is the QR? If you see, that is nothing but the magnitude of A. So A square plus and OR is the B of cos theta square. Remove it. If you solve this one, what you are going to get? B sine square theta A square plus B square sine cos square theta plus 2AB cos theta. You can see this sine theta, sine square theta, cos square theta will come out as 1 itself. This situation is very important. We'll be working everywhere. 2 times of AB of cos of theta. And finally, I can say this is R square, so R will come out as under root of A square plus B square of 2AB cos of theta. Is that clear, Kaplan?
Yes.
This is a resultant coming out of a triangle's law of vector addition. We can say it is same. There is no difference. Okay, we have got the same thing.
And
Now
sir,
let
like
us.
one. Okay.
Okay, what happened?
Nothing.
Okay, it should be cos theta. Yeah, look, in the next part, if you see, I have calculated the result. Now my task is to calculate the angle. Look, because this is the resultant, okay? So I have to calculate the angle of this resultant. Let's say this angle alpha, and how much angle this is making with this particular length, okay? Whatever it is. So basically, you can take any angle you want to take, like with A, with B, whatever you can say. So what is the angle made by this? I can simply say that tan of should I use a tan? Not. Let's not use a tan. For technical advantage, we can do either thing, so will work. Generally, when we have to calculate the angle, we prefer the tan value. Okay? So, what is the angle? You can simply say that tan of alpha is equals to perpendicular. What is the perpendicular? That is base for this OPQ. Okay, OPQ. Look at the OPQ. From there, we can calculate this alpha by saying tan alpha is nothing but perpendicular on the total base. Okay, so this will come out as b times of sine theta divided by a plus b times of cos. Understood? Look, you had to calculate angle with respect to A. So what angle comes out as B sine theta base as A plus B cos theta. Is that clear?
Yes.
So you can do the same thing if instead of if I ask you what is the angle between A and what is the angle between resultant and B, replace
So
these.
why is it like B sine theta?
Look now here. Look, I took this triangle, right? O, P, and Q. Okay, this was my alpha. This was my alpha. So what I said, tan alpha is nothing but what is the perpendicular? I said perpendicular divided by the total base. So here if you see this perpendicular is nothing but the b sine theta.
So why is it named B sine theta, sir?
This is not the name, this is the value which came, wait a second, I'll come up with this.
Okay, because it's attached to this B vector, B magnitude.
Okay, now look, this was a b vector, right?
Yeah.
I said resolve this. You know when resolving it, because you have taken one resolution in this direction by this taking this theta, other should be perpendicular to this, right? And perpendicular to this is nothing but this is the perpendicular, right?
Yeah.
I can say this is also this is b sine theta because one resolution, that's it. And I can say if you see carefully, the length is same, right? And if length is same, so I can say this is also b of sine theta. I can say this, right?
Yes.
If you are not able to get it, you can go in another way. Tan of sine of theta. Go with the sine of theta is equals to perpendicular divided by base, that is b magnitude. What you have got b times of sine theta. Either way you go, you will get the answer. Clear? Look at this. Look, we need very much clarity in this concept because if we got it very clearly, then for a parallelogram, I will just copy paste whole of the thing whatever I have written. Just one slide change will be there. Okay. So take a minute, take a pause for a minute, and go through the whole of that. Will just minimize this screen. Is, Bhavana, is it clear? Okay, look,
Yes, sir.
go through line by line. Okay, go through line by line for each word.
Okay,
How we
sir.
can come up with. Okay, take 5 minutes because look, this is very important. Okay, if you are able to get the triangles law of vector, the parallelogram law of vector comes up very easy for you. Okay,
Okay, sir.
due to the similarities. Okay, clear or have some doubt?
Sir, I'm in the last one.
Okay, which step?
Root over a square plus b square plus 2ab plus 3.
Let's see, this resultant part.
Yes.
What's the doubt here?
Sir, I'm saying doubt, like, I'm going through it.
Okay, okay, yeah, fine, fine. I'll just minimize that.
Certain.
Done, huh? Any doubt here?
No, sir.
All right. Okay, so I will just try to go with the parallelograms, analytic method of parallelogram, but okay. So what I'm going to do is I'll just take the upper part, copy it, and we'll paste it. So this is what the parallelogram is also. Just some changes needed. So first the naming should be different.
So I can't see.
No, this is we are on the same page.
Okay, I've repasted it. Okay.
Yeah, I have just repasted the about thing. Parallelogram
Yeah, I can see.
law of vector. Okay, what was the parallelogram law of vector? Okay, what the parallelogram law says that uh, let's remove the things from figure. Parallelogram says that um, if you have two adjacent side of a parallelogram, mean to say I can say these are two adjacent side of a parallelogram. Okay, then the resultant, then the okay. So I'll remove this also. Okay, here's an what is um, now look as per the what does the parallelogram law says? It says that if you have two adjacent side, if you have two adjacent side of parallelogram, or you can say if the vectors if two vectors a and b, this is a vector and this is b vector, if they are representing two adjacent side of a equal what you can say parallelogram of triangle, so you can say the diagonal coming out of the same node will result you the resultant of these two vectors. Is it what the parallelogram says? Hello, Bhavna.
Yes, sir.
Okay. Is it what the parallelogram says that if you have two sides which are representing the two adjacent sides of a parallelogram, okay, then the
Okay,
resultant,
sir.
then the diagonal coming out of it gives you the resultant of it. You can see if I extend these lines little bit from here, it is forming a kind of a parallelogram, right?
Yes.
You can see this, and if I extend from the top part also, how you can see how it is forming a parallelogram. This here, okay, you can see it is forming it has formed a parallelogram. So we can simply say that yeah, this is forming a triangle. So if you see carefully, this is b, right? This is b vector. Can I say this b is parallel to this line because this and this are parallel because of the parallelogram, this and this is a parallel. So I can simply say I will just go through the previous naming. What was that? This was q, this was p, okay. Q p, this is r, s, assume s. Due to parallelogram, due to parallelogram, ps is parallel to the qr, okay, and sq is parallel to the pr, is it? And you know, if two vectors are parallel, we have already studied, if two vectors are parallel, then their direction is same,
Yes,
direction is
sir.
equal. But here in this is in my case, with the along with being parallel to because what happens in the parallelogram, opposite side are not just parallel, they are equal in magnitude also. So here I can simply say that because it's a parallelogram, sq vector is equals to pq vector, pr vector, right? Is it pr, sq and pr vector? Yeah, it's fine. Okay,
Yes,
can I
sir.
say this? And also I can say that a qr although QR vector parallel to SP vector. Although this part is not important for me, because this is not an important part for me, but still not useful in this problem. But you can just remember
Okay.
this is not useful. This so Kirtan, Bhavna, I can simply say that if this SQ and PR is equal, I can also write this as B. Can I say this?
Yes.
Now, if you see, do I really need to remember this part, this extra portion which I included in this new problem? You can see I have got this problem as the previous problem again. This is A, this is B, this is the third side. Isn't it like I'm again going to solve the triangle's law of vector? Look at this.
Yes.
Can you see like I have again got into the similar condition as per the triangle's law of vector,
Yeah.
right? So I can simply say that I will not solve it again. I will simply uh, this is one. If you put the naming it to O, we have got everything is the same. What is that? You have a triangle OPQ. I have O, P, and this is Q. This is 90. You have another triangle OPR. OPR. You have got two triangles. Angle between A and B. Call it as theta because look, this is the B, this is A, so angle between them will be theta itself. This is B angle, okay? Direction of A
Yes.
unit vector, and this is the so that is the thing. You can see if you know one concept, how the other part becomes easier for you itself.
Yeah. Yes.
I know, like you will be getting the clarity of this when you'll be solving the problem. Look, when you are solving the problem now, you should just be able to identify actually the angle of between vectors, okay, and how you have to treat them. That's it. Every time we don't
Okay.
need to know whether my problem is getting solved with parallelogram, log vector, or triangle. If you see, they are nothing but we don't we are giving all the possible conditions how you can represent a vector, okay, how you can get out the resultant out of it. That's it. At the end of the day,
Okay.
by both way, we are getting the same result, same value, right? And if you see,
Yes.
we have got the same resultant value when I in the previous part when I was teaching you the I think resultant or magnitude thing when we did the magnitude part, right? Magnitude of two vectors. There also we have got the same result. We didn't bother about the whether it's a triangle of vector or whatever it's law of vector. I just told you if you have two vectors, if you are able to make them align tail to tail and head to head. For example, this is one vector, this was one vector, this is another vector. If you are able to align them uh, like this, so you can simply say that whatever the angle between, you can apply this formula, you will get the result. Okay, this is what we
Okay.
had a discussion in the previous one. So I think I should not go again by using the same thing, right? Because the same thing worked for this one also for above. Okay.
Oh. Okay.
Okay. So I'll just go through some problems. Let's solve it and move further. Okay.
Okay.
Okay. So Bhavna, one problem for you. You are given a two force vectors. It's too big actually. No, here I will do. Two forces, 10 Newton and 15 Newton, are acting at a point at are at a point at 45 degree of angle with each other. Find out magnitude and the direction of the resultant. Find magnitude and direction of the resultant. This is what you have to solve. Okay? When I say direction of the resultant, you can calculate it with either of the vectors. Okay, most probably you can calculate with the first vector which I gave you, that is 10. चल रही हूँ मैं अभी. Bhavna is solving the problem. Okay, have you got the answer or is still solving?
So I'm doing it.
Okay, okay. You can do it.
So is that coming in decimal?
Decimal, which part? The magnitude or the angle?
Magnitude.
Magnitude won't be in the decimal. How much? Yeah, it's in decimal. Okay. How much you're getting? It's in the decimal. Okay. Basically, when you round
I'm
it off,
saying I'm getting, yeah, root over 537 point some.
537 point something. Okay, so this will be coming out somewhere around 24, is it?
Yeah, yes, sir.
Oh, it's correct answer. The main focus should be the 10 like angle. Okay, what is the angle between them? That was the main motive. Generally, in the problem, it will not return the angle. It will say give me the direction. So you can see this is a vector quantity, so you have to give the direction also. So you can say it is at the angle theta or is it angle phi alpha from these vectors. So it will be a kind of direction itself. Okay, you don't have to use I and j cap for these vectors. So you can simply find out the angle between any other vector. Okay, whether it's 15 or 10.
Okay.
Always try to go with the first vector which they have given. For example, here they have given 10 vector, so go with the 10. Okay.
So
Okay,
I'm getting direction to in decimal
you are getting how much?
around 27.
Is it 27 or 127? Okay, fine, whatever it is. Basically the angle will be 120. What is that? Yeah, it will be 27. Correct answer. All right, Bhavna, so we are done with the.
Because like the root to value
Yeah,
is
yeah,
included in it.
that comes upon,
Oh,
so no problem. So yeah, we are done with this parallelogram and all these things. Okay. Some
okay.
things are left like the main part is still left basically. The uh, okay, I didn't taught you the component part. Forget this. Okay. Uh, Now we are left with the product. Okay, how we are going to do the product of two different vectors. We don't have a division part. How you can divide the two vectors? Okay, we have a product part. That's it.
Uh,
After this product part,
dot product and cross product.
yeah, dot product and cross product. Okay, after this, we are done with the
Okay, sir.
vectors. All right, so that's all for the discuss. I will try to cover up the rest of the part in the next class. Okay.
Okay, sir.
All right. Goodbye, Mohammed. I'll end the session right
Okay.
there.